So thanks, Richard, for the kind introduction. I'm an environmental scientist, and we're really in the top 3 of the most unpopular professions. I would say right after the undertakers, we're up there. We really know how to drain the joy from a room. We're party poopers. We spread despair and hopelessness. And so to do things a little bit differently, I have a New Year's resolution, which is I want to be more radical. Inspired by this quote, to be truly radical is to make hope possible rather than despair convincingly. So if you allow me to, let's be radical today. Let's share hope instead of despair. So that's what I want to do. Why do I think we have reason to be hopeful? Well, we heard great presentations this morning. People are really taking this issue of climate change seriously, and we're working on solutions. We're working together on solutions, and importantly, we've got you here. You are business leaders. You are the people who have the power to change the world. I mean, money makes the world go round, right? So let's not make it go round the bend, but let's make it go in the right direction. I'm getting weird feedback from the microphones here. Okay. Well, maybe should I walk away? Is that better? Okay, I'll walk here. So I would like to invite you to join me on a journey to look at the situation of packaging, climate change, that we started about, I would say, 15 or 20 years ago. And what I want you to take away from this presentation is pretty much what speakers in this morning's session already said, and what Kim also just reiterated now. It's complicated, and we can't just focus on one aspect. We live in a complex world. Our planet is a complex ecosystem, and I'm going to try and highlight one little point of that, which focuses on chemicals. Okay, so let's start our journey. This is the classic wine packaging, as you know it. It's a glass bottle. Maybe this is a bit better now. And what we heard already this morning is that one of the disadvantages, of course, of glass packaging is that it's heavy. And when we transport it across long, long distances, we produce many carbon emissions, right? So glass, of course, keeps the wine, it conserves it for decades, centuries maybe, so it's actually good packaging. It does its job really well, but it has this aspect of being heavy and associated with high emissions. So one of the quick fixes 10, 15 years ago was let's move into lighter packaging. So this is a picture that a friend of mine sent me about 10 years ago. It's a plastic bottle. Picture taken on a commercial airline flight in the economy cabin. They still have those plastic bottles, by the way. And this one had a very bold statement on it. The label reads, "Enjoy the benefits of our plastic bottle, as good as glass for the wine quality, better than glass for the planet and you." I didn't Photoshop this. This is real, right? And this is quite a bold marketing statement. I think we can agree on that. And so I kind of, it intrigued me. So I thought, okay, well, let's have a look at it. And there's 2 statements here, better for the planet and better for you. So let's look at the first one. So, better for the planet. Now, a picture I took about 11 years ago, I think. This one maybe 7, 8 years ago. And we've all seen more drastic pictures than these, right? I mean, plastic pollution is an issue. It's in our faces. It was mentioned earlier, the Blue Planet 2 sparked this huge activism really on the political level. And, I think it's good we're talking about this because this is a problem. This is a global crisis. Plastic is persistent. It's not going to go away. It stays there in the environment. It kills species. It affects seabirds. It affects mammals living in the ocean. But what also happens with plastic is that it weathers. It breaks down. And it doesn't go away chemically. It doesn't biodegrade. But it breaks down into these smaller and smaller and smaller particles that we see here. But some of them also can't be seen. They're also known as the nanoplastics. When they get into very very small sized particles. And these are not natural particles that are increasing in the environment. And I lack the creativity to think of how we can clean these up. So here's your bit of despair. I'm going to sprinkle a bit of that in there. Okay, but there's another aspect. So this is the planet. But there's another aspect I want to talk about, and that's chemicals. And these are the subparticle level elements that we can't see, but they're also an issue. So let's look at the chemicals. So here's a very simple animation to explain how food packaging interacts with your food. So imagine your bottle of wine, whatever material you prefer it in, and then your packaging is made up of chemicals, right? And those chemicals, they can transfer from the packaging into the food. So that's basically what it looks like. And the red dots are the little molecules, right? So you can imagine that. But what can also happen is that you can get chemicals that transfer from outside of your packaging, depending on your packaging material properties. So these can be printing inks or the adhesives you use to stick your labels on, or it can also be environmental contaminants, depending on where you're storing your packaging, right? So they can get through the packaging into the food. By the same token, and just keep this in mind, we'll get to that later, chemicals from your food can also be absorbed by your packaging. Right? So that could maybe be flavor or nutrient molecules that get absorbed by your packaging, and this of course depends on the material properties of your packaging. So this process, this transfer of chemicals from packaging into food, we call it migration. I know it's an unfortunate term, but that's what it is. So this chemical migration. Migration is accelerated if we have higher temperatures. It also increases over time, so imagine long storage times. That contributes to chemicals migrating. It depends, importantly, on the chemistry of your foodstuff, but also on the chemistry of your packaging. That's a really important one. And something that people sometimes don't think about, it also depends on the size of your packaging. So imagine you have packaging surface in relation to the volume of your foodstuff, and if you shrink your packaging, you increase the surface to volume ratio. So smaller packaging will have proportionally higher chemical migration, so per unit of food. Okay, so why am I telling you all of this boring stuff? Does it matter? I mean, okay, we know chemicals can leach from plastic, they can leach from paper and so on into food, but these are always low levels, right? Does it matter? Well, you could say, does the dose makes the poison? I guess most of you have heard of Paracelsus. He's actually famously misquoted. He didn't really say that, but let's not go into that now. So, the dose makes the poison. Well, yes, it does, but it's not always true for every type of what we call exposure in toxicology. So, just imagine you're drinking 18 liters of water, right? Now, if you drink those 18 liters of water in 1 hour, what happens? You drop dead, right? Your body can't handle it. It kills you. The dose makes the poison. If you drink those 18 liters of water over the course of 9 days or so, you'll feel quite good because you're drinking 2 liters of water a day, and that's what people say is good. So this is Paracelsus' world. It's acute toxicity. It's do you drop dead? Do you see an immediate, instant effect? What we are looking at when we look at these low levels of chemicals that leach from packaging into food is something very different. We're looking at chronic toxicity, and we're looking at low levels of chemicals that get into your bodies across your whole lifetime, when you're a fetus, when you're an infant, when you're a child, a toddler, when you're in puberty, when you're an adult, and in old age. It's across your whole lifetime. You don't drop dead from these chemical exposures, but they have an effect on your body. And we know that a lot of chronic diseases are increasing in our population, and we know that chronic diseases, in animal experiments at least, can be caused by exposure to certain chemicals like BPA, Tiago mentioned it, perfluorinated chemicals, and so on, cancers, allergies, obesity even, associated with exposures, low-level exposures to these chemicals. So if we're talking about solutions for packaging, I think it's important to know that if we have solutions where we're kind of shifting the burden towards the society in a sense, because we have to pay for these chronic diseases, we have to pay for the treatment costs, that's not a good solution. That makes a solution that becomes tomorrow's problem. So packaging that leaches hazardous chemicals or untested chemicals into food is not a good solution, in my opinion. So one message I want to share with you, and I'm probably running out of time, yeah? Environmentally friendly packaging is more than low carbon. Okay? Who of you here has heard of the planetary boundaries concept? You put up your hand? Okay, very few people. So I'm going to take a minute to introduce this, Richard. So the planetary boundaries concept is a very pragmatic, science-based approach, right? You can think of our planet Earth as one big ecosystem, and you can divide that into 9 critical sub-ecosystems. And scientists have, for some of these sub-ecosystems, defined thresholds or boundaries, which means that if we exceed those thresholds or boundaries, the individual sub-ecosystem will destabilize. And it has the potential to destabilize the overall planet's ecosystem, right? So you see climate change is up there. That's, of course, an important one. That's what we're talking about today. But all of these sub-ecosystems have the potential to destabilize our planet's ecosystem, planetary health. And importantly, they also interact with each other. And that was shown so beautifully in the presentations this morning. Biodiversity, it's one of the critical aspects here. Soil fertility, soil health is one of the critical aspects here. Nitrogen, phosphorus loading, freshwater use, and so on. So when we look for solutions, please take this into consideration. Don't look for the quick fixes that solve the issue maybe in the short term by reducing carbon emissions and so on. But if you produce chemical pollution in the environment, and that, by the way, is the novel entities here, and there's a question mark because we really don't understand it very well yet. That's going to cause problems for tomorrow. So I know I'm asking a lot of you. This is complex. I'm happy to help. I'm here to talk. I have access to a whole bunch of other scientists who understand chemicals in the environment, to understand human health and chemicals. Let's start a discussion that is a little bit wider, open-minded when we talk about solutions going into the future. I don't know if I have any more time. You're going to kill me if I keep on talking.
The
organizers
really,
will kill me.
I don't know.
Okay, I'll just keep on going until you turn off my microphone. So one of the things that, yeah? Okay.
You can check it out with him.
Sorry, I didn't understand what he said.
I think he's saying, can you just
1 minute. Okay,
yeah.
Great, good, I can do 1 minute. So recycling. We heard a lot about recycling. Is this the solution? Now, go back to the slide I showed you about migration, right? I also told you that packaging can suck up chemicals from the food that it contains. It can also, certain types of packaging, it can also suck up chemicals from the environment. And people do funny things, like you go camping, you put your petrol for your cooker in a plastic bottle, and when you've done with it, you throw the plastic bottle into the recycling stream. The chemicals from the petrol will be sucked up in that plastic. And so recycling, when you talk about plastic and paper, is not a trivial thing. It's actually a really complicated thing. To give you a concrete example, people are starting to reuse coffee cups, mugs. They take their refillable mugs. Now, in Europe, we found that the black lids, the black plastic lids of these mugs, contain brominated flame retardants. These are very toxic chemicals. They're not allowed to be in food packaging. They get in there because of illicit recycling of waste electronic plastics, which is full of brominated flame retardants. Now, these plastics look exactly the same as other plastics, but they're full of these toxic chemicals. And that's one of the big things that we need to talk more about when we talk about plastic recycling. It's not so simple, okay? And also, as Thiago mentioned already, we distinguish between permanent and non-permanent materials. So metal and glass are the non-permanent materials that you can recycle indefinitely. Of course, you need high energy input. So I would argue it's actually good to shift towards deposit systems where you refill the containers 50 times or so before you turn them into new containers. That would be the best in terms of environment and also in terms of chemical migration. Okay, and with that, I'll stop. You can have my slides if you want to. I'm happy to share them with you. I also put together a bit of resources, background information, if you want to dig into the details here. And last pitch, we're doing a workshop on the 25th of October. It will also be web streamed, so if you don't want to or can't travel, keep your carbon footprint low, join us on the internet. Thank you very much for your attention.